and you should be able to start drawing the reinforcing in there. Now remember, you don't have to draw every single bar. So for example, also you don't have to place the reinforcing, you don't always have to replace it exactly where it should be. So you'll be doing the outline of the slab, and you'll be doing the footing, because we're looking down on it, it's going to look like that. And there's bars running this way, and there's bars running that way, right? You've got a sectional view that looks that way, and we've got one that looks that way to show you which way the bars go. And so you start putting in your bars, and I know there's one that goes like this, and it overlaps with its mate on the other side, which does exactly the same thing. So in plan view, that's going to look like that, and there'll be a donut on the end of it, the same size as the bar, same width. That's a P-line, and you need to give it a thickness. So Ingrid would have shown you how to do that when you did your retaining wall in the drawing class. So you make sure you do a P-line, and then you can right click on it and go to properties and give it a thickness. Be careful of that, because one of the options has 0 at one end and whatever the bar thickness is at the other. That'll look really odd. So it's the overall width, thickness, width, I think it is. Or you can go P-edit, and which is the way that I used to teach the first class. So type P-E-D-I-T. Click on the bar, and you've got quite a few options there, and one of them is the width. You can type in whatever the width of the bar is. It's best in plan view that you show the other bar right hard up against it, like that. Okay. Now it is rather difficult to tell whether this is coming back this way or whether it's going that way. So you can't do much about that except to tell you that in the real world, when we do reinforcing, we try to show two views of every bar so that you can see whether it's going up or going down. So this view here would normally be associated with that. But for your assignment, I don't want to see that. In fact, you'll get a mark off, or half a mark off, if you show that for the assignment as part of your slab. Okay, so it's actually easier, you're just showing the slab. I don't mind if you draw it below, just so that you can relate each bar, because obviously if there are bars going, you know, I can't remember whether they're on top or below. I think they're on top. So, you know, you can sort of go, okay, so we've got a bar going up like that, and so you're relating this one to this one. A lot of students like doing that, then they can, you know, do it that way. But if you please, when you finish doing that, move that down out of the viewport. You're not wasting your time, because you will need to draw that for your elevation drawings, right? Because we have to, basically my sketches, you've got to reproduce those, but properly, not with curved little arrows and the things that I've done. You do do it according to the way you were taught in technical literacy, with lined up text and etc. Plus today we're going to learn a little bit about what we should call the members, etc. And of course you can't just put a bar like that. You've got to do a circle which is 2 times the diameter, and we've got to take that down, and we've got a delimiter bar here and a delimiter bar there, and basically an arrow pointing to it. Now that will be harder, in most cases it will be hard up against the cover. So if we have the cover like that, The bar with its thickness will be will be hard up against the cover, right? And then the arrow will go to it like that. That tells us that that bar goes from there to there, but we don't know how many of them there are, we don't know what the spacing is, and we don't know, unless we zoom in and list it, what the actual diameter of the bar is. So all that gets written on top of the bar, not on top of this line, that. This line should be a normal thin line that you draw in AutoCAD for everything. This is your thicker line along here. This really does help when it comes to reinforcing schedule. What you've got to be careful of is if these two are twins, you know, they're just one's mirror of the other, but they're the same bar. What you've got to be careful of is that on the schedule, if there's 40 that way and 40 that way, on the bar schedule you'll call it up as 80. But on the drawing it'll be 40 and 40. Right? Very big mistake that students make is they see their bar schedule as 80 and they go 80, 80. And that's completely, imagine my friend the big steel guy that cuts the steel and has all the horrible stories on site, will suddenly, he'll be very angry. He would want to get in his way if you told him to cut 80 of those and there was only 20 to cut or something like that. So, this is worth 7 marks. It will be accompanied by some notes from your concrete notes. Obviously this drawing is in millimetres, would be a good first note. But you can also add a few things in there like the MPA of concrete after 28 days or some of the other ones that are in there in terms of that. And also in terms of reinforcing bars. The schedule's straightforward. Please put the bars in order, mark order. So I think I've given you the marks for the bars on the sketch, like 1601, 1603 or whatever. Use those numbers but put them in the 01, 02, 03, 04 order. Firstly, you should always do that, and secondly, that's how I mark them, and it stands out pretty quickly if you haven't put them in order, because I've got a sort of a template that I'm marking with, going yep, 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 and then, oh, this is weird, nothing's, it's not in the right order, they've given me the wrong bars. So you make it harder for me to mark, that's more of my time. More my time means more negative marks, and also that's what industry demands. Okay. So you should be able to do that. You should be able to do the reinforcing schedule from last week. You should be able to also do most of the quantities. With the concrete quantities, ignore the reinforcing, pretend it's not there, just the concrete is what I want. So it is quite an easy shape to quantify. There's also some filter material, a pipe, and a couple of other things in there to schedule as well. What you can't do and don't know about yet is the steel, which you'll find out about today, both in the lab and here. And although the timber is very easy, because there's only 9 purlins, I think, and the size is straightforward, you still got to do the timber class to work out how to call it up and how to schedule it. So that'll be a sort of a last minute thing in terms of next week. The 3D we'll get on to the following week, and then some of the other bits and pieces will drop out of some of the lecture notes from the first 4 weeks. The 3D is something that is easy to get overexcited about. What I mean by that is you're actually drawing something that starts coming out of the page in 3D, and it's kind of fun, and especially when you start to get exams coming up and you're swatting for fundamentals or something like that, structures, and you're just having fun drawing this 3D thing. You can go overboard. I've had a Russian student that drew a plane. He got it off the internet, an AutoCAD, and he put it inside the building. I've had an Indian student who decided it would be funny to put a whole lot of monkeys on a bridge. I'm not sure why. Found them on 3D. They're all hanging off this bridge that we're drawing. I had a good laugh, but he got marks off for being silly. So, I'm just saying that that's the sort of thing that happens when people don't want to study for exams. It's only worth the marks that I've allocated, so don't think that you're going to get like lots and lots of bonus marks for trying to impress me with different things. And also beware, the internet's a wonderful place for finding stuff, but you find that the nuts and bolts that have been drawn on the internet have been drawn rather they've been drawn in such a way that they take up a lot of AutoCAD space. And if you've got, on that bridge alone that we did a couple of years ago, there was something like 300 bolts. And the student put one into his drawing unaware that as he kept inserting the bolts and the nuts and all the rest, they were very finely designed. And I think we're going to have to go for a wee walk. Okay, grab anything valuable and we'll head downstairs.